Hi, we're here with Maryam Pourebadi. She's the recipient of the August Jacob Grave Student Council Award. Maryam is also a Ph.D. student researcher from the Computer Science and Engineering Department. Her research explores the use of expressive robots in clinical education settings. Can you tell us a little bit more about the motivation behind your research and what are the gaps in the existing science that you're trying to address?
Yes. So here at the Contextual Robotics Institute, we all try to design technology to make people's life easier and better. So for example, every year, 400,000 people die in US hospitals due to preventable medical errors. This is actually the third leading cause of death in the United States. So in fact, with better engineering, we could make this number disappear entirely. One of the main reasons these errors occur is that clinicians, patients, and family members often aren't on the same page, so that clinicians miss important clues and can incorrectly diagnose patients. This is where Robotic Patient Simulator, also known as RPS, comes into the picture. These systems are the first line of defense in patient safety. They enable clinical students to practice their procedural and communication skills on a very lifelike Android robot, right before treating real patients. These are amazing piece of technology. They can breathe, bleed, and respond to medication. Also, they have over 5,000 physiology variables one can tweak. Cool, right? But they look like this. So they are completely inexpressive. The main challenge with this technology is that it lacks one of the most important sources of diagnostic information, an expressive face. We convey so much information in our face if we are in pain, if we are reacting poorly to medication, or if we have stroke. So another challenge is its usability and controllability while we are running more complex simulation in a simulation and training centers. So generally in a simulation room, a team of medical learners treat a RPS, which learners can be junior trainees, like medical students, nursing students, or senior clinicians undergoing retraining and certification. On the other side, clinical educators sit at the control booth watching learners while also manually changing physiological parameters of the RPS on the fly. So the challenge is that this technology doesn't appropriately support either the clinical students or the educators. Students learn the wrong skills, often dangerously, and need to be trained. Also, educators can't run the simulations they need to. So to address this challenge, we've been working on building our new expressive patient simulator robot.
Oh, that's great, but can you tell us what makes your robot different and unique? And how can you use it to address these challenges you just mentioned?
Absolutely. So we have been working on making robotic patient simulators more realistic by giving simulators richly expressive faces, which is able to synthesize nonverbal behaviors based on entirely actual patients. Furthermore, this robot has some autonomy and access to external sensor data, which makes it able to perform more tasks independently in a simulation setting. So that we are working on designing a novel control system to use this data to make RPS adjustable to different control paradigms. In our work to date, we have developed an automatic synthesis method for mapping naturalistic facial expression on a virtual avatar or physical robot in real time. This synthesis method is based on performance-driven animation implemented as a ROS module, which maps motion from video of an educator onto the face of any embodiment. Plus, we have fabricated a new low-cost expressive RPS head with 22 degrees of freedom, which is capable of conveying patient pathologies and pain. Moreover, we have run a series of robotic-centric and human-centric experiments validating our system. Now we want to think about how to put this into practice, and to do so, we need to consider the existing workload of educators operating the robot. The educators are running more complex simulations where they need to design different scenarios or manually changing physiological parameters or do voice control and so on. However, we would like to reduce the operators' workload and improve their ability to focus on their educational goal rather than on robot control. To do so, we are closely collaborating with a team of clinicians and we are engaging in an iterative design process to create a new shared control system. This shared control system can help to share the autonomy between human and our robot. So for robots to perform more simple tasks in a controlled lab environment, a fully autonomously controlled system are often an appropriate solution. On the other hand, for dealing with complex and unpredictable scenarios in dynamic learning environments, control systems that are semi-autonomous, supervised, or partially controlled by human operators are more appropriate. So our goal is to design and make our system be able to support four modalities. One, fully autonomously displaying of facial expressions based on other biosignals. We want to have direct manual control of facial expressions. Also, we want to have direct teleoperation to be able to automatically map the operator's live video to the robot's face. And also, we would like to support pre-recorded modes, such as hemifacial paralysis in a stroke mode. And also in the coming year, we plan to test our expressive RPS and its control system with clinical educators and learners. So we hope this work help us explore robotics in new experimental learning settings.
Apart from being a very prolific researcher, you are very involved in the community of UCSD. Can you tell us what are some of your passion projects or activities you do to improve the sense of inclusion and better professional development of students here at UCSD?
Sure. So as a member of CSE diversity community, our goal is to create an inclusive environment to reach a broad set of students in diverse teams. And also we want to promote the professional life of the underrepresented groups to be better recognized by the engineering society. Also, as an elected board member of Grad Week, I co-coordinate the graduate mentorship program started by Grad Week last fall. So my goal is to ensure my colleagues have a strong support system and also enough resources to pursue their goals. Basically, the purpose of this program is to build a tighter community within our department, and is also for all members of our graduate community, regardless of their identity. So mentors will get coffee with their mentees and answer their questions about grad life, advisor relationships, research, and whatever else they need to know. The other contribution that I had recently was collaborating in organizing the Ph.D. orientation panel. It was a QA panel for all new Ph.D. students at CSE department. So we also organized an imposter syndrome presentation where we try to make new students aware of the existence of this syndrome and let them know that this is a real thing and that will happen to most of us during our academic life. And we also wanted to provide them some mental health resources available at UC San Diego.
Oh, this sounds very interesting how you're working with smaller, younger researchers. But how can you convince them to pursue a higher degree academic education in STEM? Because a lot of these kids, maybe they just want an easy job, but how do you motivate them to stay in science engineering?
Okay, good question. Actually, I believe there are many ways to motivate the young and talented generation to get involved. For example, I had a chance to be an IEEE fellow judge for the Snowball competition at UC San Diego, and also a mentor for SD Hackathon. And one of the main goals was to motivate the undergraduate students as well as children to pursue computer science and robotics field. Also, I was invited to be a judge for the WEX robotics competition to inspire high school female students to practice in technology and computing developments. And based on the feedback they gave us at the end, I believe our work increased their empathy for learning and working in this field. So I feel that the work that I'm doing, either as a researcher or as an active community member, is going to go towards something that is useful for human being. And for me, that's the most valuable thing about it.
Well, Maryam, congratulations on the award, and we hope you the best of luck in all your future endeavors.
Thank you.